Hello, everybody. Welcome to the podcast on defining and evaluating sleep health. My name is Dr. Konrad Sawicki. I am a second-year cardiology fellow at Northwestern University in Chicago. I'm delighted to be joined today by two experts in sleep science, Dr. Dayna Johnson, who's an assistant professor in the Department of Epidemiology at Emory University, and also Dr. Fink, who's an assistant professor in the Department of Biobehavioral Nursing Science at the University of Illinois in Chicago. Well, in order to understand poor sleep, we first need to understand healthy sleep. And what are some of the characteristics of healthy sleep?
Most importantly, healthy sleep should involve a sufficient amount of deep restful sleep, as well as what is called rapid eye movement or REM sleep. These different types of sleep are controlled by neurons in various parts of the brain, including the basal forebrain, thalamus, hypothalamus, and the brainstem. Multiple neurotransmitters released in these brain regions influence the brain's electrical activity as a person transitions from wakefulness through the different stages of sleep. Each sleep stage has a distinctive brain activity pattern. These patterns can be measured by conducting sleep studies with an electroencephalogram, also called an EEG. This is a test that measures the brain waves. When someone is awake, for example, the electrical activity in the cortex will appear fast and highly variable, depending on what activities the person is engaged in. The pattern shifts to a slower, more synchronized rhythmic pattern in brain activity. Neurons in the cortex and thalamus begin to produce bursts of oscillatory activity, which appear as peaks in the EEG recording. Next, the brain activity becomes progressively slower as the depth of sleep increases. The person then enters the deepest stage of non-REM sleep, which is often called slow wave sleep, due to the distinctive patterns of large and slow EEG waves. Sustaining periods of slow wave sleep is important because this is the deep, restful, restorative phase of sleep. Throughout the sleep period, non-REM sleep will alternate in cycles with shorter periods of REM sleep. REM sleep is characterized by high frequency, low amplitude, desynchronized brain activity patterns. REM sleep also involves muscle atonia. Essentially, your skeletal muscles are going limp and cannot be moved. Although the physiologic purpose of REM sleep is not completely clear, there is evidence supporting a role for REM sleep in learning and memory, and in immune and metabolic functions. People tend to experience the most REM sleep in the early morning hours. And there's also more transitions among the sleep stages in the early morning hours in most people.